Dear students, welcome to the problem solving session on continuous random variable part 3. In the previous videos, we discussed about the definition of continuous random variable and its properties, and then we deal few problems on continuous random variable. In today's session, we are going to deal problems on cumulative distribution function. Just let us recap the definition of cumulative distribution function. The notation is capital F of x, that is equal to probability of x less than or equal to x. For the continuous random variable, for a given PDF small f of x, capital F of x is integral minus infinity to x small f of x dx. So let us see few problems on finding CDF. For a given continuous random variable with PDF f of x, we have to find the cumulative distribution function capital F of x. Hence, we have to find the probability of x lies between 3 by 2 and 5 by 2. To find CDF, it is very important we have to understand the limit. Here, when x less than 0, answer is 0. Similarly, when x greater than or equal to 2, also my function is 0. So when x less than 0, it is 0, and the next interval of x is between 0 to 1, and the next one is between 1 to 2, and finally we have x greater than or equal to 2. So for each interval, we have to find the corresponding CDF from the given PDF. And we know that capital F of x always lies between 0 to 1. So the first case, when x less than 0, my capital F of x is 0. So it is done. Next, when x lies between 0 to 1, we have to recollect the CDF formula, minus infinity to x f of x dx. But according to our question, we see when x greater than or equal to 0, the function exists. So my lower limit is going to be 0. Therefore, integral 0 to x f of x dx. Now, my x maximum value is 1. Therefore, when x lies between 0 to 1, the corresponding function is x. So, integral 0 to x, my f of x is x into dx. Integrating this, we get x square by 2, 0 to x. Substituting this, we get x square by 2. Therefore, the CDF for the given interval 0 to 1 is x square by 2. You can see the typed version. Next, for the interval 1 to 2, here you should be very careful. Capital F of x means cumulative distribution function. I cannot find simply from 1 to 2. Even it is given as 1 to 2, we have to start with 0 and we have to go up to 2. Since my f of x is integral 0 to x f of x dx, here my lower value is 0. So I have to split the problem as 0 to 1 f of x dx plus 1 to x f of x dx. Now we have to go back to the question and we have to check the function f of x at the interval 0 to 1 and then at the interval 1 to 2. In the interval 0 to 1, my f of x is x, and at the interval 1 to 2, my function is 3 by 2 x minus 1 whole square. Therefore, integral 0 to 1 x into dx plus integral 1 to x 3 by 2 x minus 1 whole square dx. And we know that integral x power n dx is x power n plus 1 by n plus 1 provided n is not equal to minus 1, and integral ax plus b whole power n dx is ax plus b whole power n plus 1 divided by a into n plus 1. Therefore, the integration is x square by 2 0 to 1 plus 3 by 2 x minus 1 whole square integration is x minus 1 whole cube. Here the coefficient a is 1. So simply we get x minus 1 whole cube by 3 integral 1 to x. When we substitute the upper and lower limits, the first content is 1 by 2 minus 0. The next one 3 by 2 into 1 by 3. When I substitute the upper limit, it is going to be simply x minus 1 whole cube. When I substitute the lower limit, it will become 0. I can cancel this 3 and finally I can write this as 1 by 2 plus 1 by 2 into x minus 1 whole cube. So CDF for the interval 1 to 2 is 1 by 2 plus 1 by 2 into x minus 1 whole cube. Next, finally, x greater than or equal to 2. Now we have to go to the question and we have to check what is happening when x greater than or equal to 2. Between 0 to 1 it is x. Between 1 to 2 it is 3 by 2 into x minus 1 whole square. 0 otherwise. That means when x less than 0 the function is 0. When x greater than or equal to 2 the function is 0. But we are founding capital F of x. After 2 we don't have any interval. Since f of x lies between 0 to 1, the final interval always we have to write f of x equal to 1. Since it is cumulative distribution function, we are adding everything. Since the total probability is 1, so the final value for f of x is always 1. Done. Next, we have to write this in a proper format. First, for x less than 0, it is going to be 0. When x lies between 0 to 1, we found this is x square by 2. When x lies between 1 to 2, we found this as 1 by 2 plus 1 by 2 into x minus 1 whole cube. For x greater than or equal to 2, it is 1. So we have to write the cumulative distribution function in a proper way like this. Hope you understand. When probability of x lies between sum a to b, that is equal to f of b minus f of a, provided a less than b or b is greater than a. So easily we can find the probability using CDF. Now using this property, we are going to find probability of x lies between 3 by 2 to 5 by 2. Now we can express this as capital F of 5 by 2 minus capital F of 3 by 2. Just for your understanding, I am writing in decimal, but it is not necessary. So f of 2.5 minus f of 1.5. Now we have to go to the CDF. 2.5 means it lies here. Therefore, my f of 2.5 is 1. The next value is f of 1.5. 1.5 lies between 1 and 2. I'm going to write in terms of fraction. Simply f of 3 by 2 is 1 by 2 plus 1 by 2 into 3 by 2 minus 1 whole cube. We have to simplify this to get the answer. Therefore, 1 minus 1 by 2 plus 1 by 2 into 3 by 2 minus 1 whole cube. Simplifying this, we get the solution. So it is 1 minus 1 by 2 plus 1 by 16. When we take LCM, we get 8 plus 1 by 16, that is 1 minus 9 by 16. Finally, we get the answer 7 by 16. Hope you understand, students. Even we can solve the problem directly by taking 3 by 2 to 5 by 2 f of x dx, but this is the easier way. Whenever we find CDF using this formula, I can find the probability in a very simple way. Now we learn how to find CDF from PDF. In the next problem, we are going to find PDF from CDF. For a continuous random variable, the CDF is integral minus infinity to x f of x dx. By the fundamental theorem of calculus, the relation between CDF and PDF is derivative of capital F of x is equal to small f of x. So using this result, we can find PDF from the given CDF in a very easy way. If it is discrete random variable, probability of xi is equal to CDF of xi minus CDF of xi minus 1. Now let us see one example problem. Here cumulative distribution function is given. We have to find the corresponding PDF. Since capital F of x is 1 minus 4 by x square, we have to find f dash of x. Recollect the differentiation of 1 by x power n formula minus n divided by x power n plus 1. So here differentiation of capital F of x, or simply we can write f dash of x is nothing but 0 minus 4. 1 by x square differentiation is minus 2 by x cube. So minus into minus plus 8 by x cube. Therefore, when x greater than 2, my small f of x is 8 by x cube. And when x less than or equal to 2, my small f of x is going to be simply 0. And we have to write this in a proper way like this. The PDF f of x is equal to 8 by x cube when x greater than 2. 0 when x less than or equal to 2. Hope you understand. For more clarity, let us do one more problem. For a given CDF, find PDF and then evaluate these two using CDF. Just we have to differentiate this. Now for x less than 0, it is already 0, so we don't want to do anything. When x lies between 0 to 1 by 2, the differentiation of x square is 2x. My capital F of x is 1 minus 3 by 25, 3 minus x whole square. When I differentiate this, we get 0 minus 3 by 25. Differentiation of 3 minus x whole square is 2 times 3 minus x into 3 minus x differentiation is minus 1. So simplifying this, we get 3 2s are 6 divided by 25 minus into minus plus into 3 minus x. And when x greater than or equal to 3, it is 1. When I differentiate this, we get 0. So we have to write f of x in a legible way like this. When x less than 0, it is 0. Between 0 to 1 by 2, it is 2x. Between 1 by 2 to 3, it is 6 by 25, 3 minus x. And when x greater than or equal to 3, it is 0. Next, let us evaluate probability of mod x less than or equal to 1. We know that mod x less than or equal to 1 is nothing but x lies between minus 1 to 1. So according to our formula, this is nothing but f of 1 minus f of minus 1. Now we have to go to the CDF. We have to find f of 1 and 1 lies between 1 by 2 to 3. So just substitute the value 1 here. 1 minus 3 by 25. 3 minus 1 is 2 whole square. So 1 minus 4 3s are 12 divided by 25. Simplifying this, we get f of 1 is 13 by 25. And the next one is f of minus 1. So minus 1 is less than 0. Therefore, from the question, we found f of minus 1 is simply 0. Probability of mod x less than or equal to 1 is f of 1, that is 13 by 25, minus f of minus 1, that is 0. My answer is 13 by 25. Next, we have to find probability of x lies between 1 by 3 to 4. That is capital F of 4 minus capital F of 1 by 3. Let us go back to the question. I need to find capital F of 4. Since 4 is greater than or equal to 3, directly I can write the answer as 1. And next we have to find f of 1 by 3. 1 by 3 lies between 0 to 1 by 2. The corresponding function is x square. So 1 by 3 whole square, that is 1 by 9. Therefore, probability of x lies between 1 by 3 to 4 is 1 minus 1 by 9. That is simply 8 by 9. Hope you understand, students.
Thanks for watching. Hope you found this video helpful. Subscribe to our channel and share it to your friends. See you in the next video. Bye bye.